Hello, hello, hello. I'm ready to knock out everybody codes quest 8. Got my shut up GeForce experience. Got my quest 8 right here. Let me get all the smart start. So just this file. Let's drop those old ones. And we are ready to not look at OBS to knock out quest 8. We are 2 or 3 days away from the halfway point of everybody codes. Let me look at that real quick. Yeah, total of 20, so yeah, we're about a little over a quarter. Here we go. Let's do this. My input of 13. This means literally nothing to me. I love an input of 13. Let's grab the real input. It's a bigger number. Okay, great. So the first one that we've actually had a number for. That's neat. Okay, so we're building a thing. Oh, I bet there's some algorithm for this. This is tough. Okay, so 13, the final width is 7 blocks. There's literally a mathematical algorithm for this. I don't know it, so I'm not going to get pretty high on this one. One of the location, thickness of script layer, thickness of all edges be 1, adding a new layer, placing the ground, left and right. Am I building a pyramid? 13. The following shrine can be built to complete the final land, an additional 3, marked with the $sign. The final structure's width is 7 blocks, so it's basically figure out how many I can make in a pyramid. Okay, so this is some kind of area math. Oh, your final answer is the product of multiplying the missing by the width. Ooh, okay, my math-only solution just got exploded. So I have 13 blocks, and I just need to build this. So, yeah, 2, and then for every one, you go up, left, up, left, up, left, up, left. You fill them in. Okay, I don't know the cool way of doing this, so I'm just going to do it the way my brain sees it. I'll call this a let. Cost blocks. It's an array of blocks. Do we always start with 1? Let's assume we always start with 1. So notes minus 1. X 0. Y 0. And then basically I need to go to this block and go every left, up, right direction and try and place a block. If there is no block there, then I place it. If I run out of blocks, then I need to do this thing where I determine once I hit the layer. It's basically a new, what do you call this? Okay, so I start here, and I'm gonna go left, right, up. It's when I reach a new Y coordinate, I guess, is when I determine a thing. So here's the, I'm imagining a world where I only have 5 blocks. So I'm gonna go here, I'm like, boom, I reached it. I place 1, then I need to calculate how many to get to the next. Okay, so let's try. My mind is not mapping this correctly. L for 1 is layer. Layer 2. Okay, what's the rule here? You can only place in a place that is touching the previous layer. Okay. My mind is just failing on this one. So for let layer equals 1 while false cost b of, my mind is completely not absorbing this problem. How wide and how many blocks there must be symbolical, some symmetrical shrine. I really am not seeing this one. Okay, nope. This is an algorithm I can figure out easily. So when I'm false, I want to go through all the blocks. For const dir for const directions equals so same, you go up one. No, the first one, your x goes to the left, you don't go up. Second one, x goes to the right, you don't go up. Last one, you can look up. Okay, so for block of blocks, yeah, so you look left, up, and right. So let's destructure this. X, Y, L. So if I'm looking at the block and it's not the layer before mine, so technically I'm building layer 2. If L not equals layer -1, continue. Don't need to look at the 1 if I'm building 3s. I only need to look at 2s. If anything, when I'm building these layers, I can push new blocks to look at, but that's an optimization. For const xo yo of directions, const and x and y equals x plus xo, y plus yo. Hey, it's a yo-yo. If const existing equals blocks dot find b dot x equals nx, and b dot y equals ny. Existing, continue. Otherwise, congratulations, we just found a blank space that doesn't have one of our predecessors. It doesn't have a block at all. Const next layer equals right here. How do I know when I'm done placing them all? Basically it's iterating through the layers, right? Yeah, so next blocks. For layer equals 2, layer true, layer plus plus. Congratulations, you just got upgraded to a for loop. There we go, and what we want to do is, if it does exist, next blocks dot push, which is x and x, y and x, or ny, l layer. Okay, good. So now we have that, and here comes the trick. So if next blocks dot length greater than blocks remaining, basically I'm about to place more than I have, then const missing or needed for next layer equals largest minus smallest. So next blocks dot length minus blocks remaining. Turn number of blocks at bottom, so left blocks with x 0. Return needed for next layer times blocks with x0. Let's rename that. Good. Else, congratulations, blocks dot push next blocks and blocks remaining negative equal next blocks dot length. Good. We decrement. We do all the things. Turn numlac back on. I'm feeling pretty good about this. I feel like I'm missing something. Right here, it's a 0. So it's basically just counting. Blocks of layer equals blocks dot reduce a b a dot x triple equals 0. Nope, it's a y. It's a y equals 0. So it's a plus. No, b dot. And congratulations, you just got turned into a number. You boolean. Start with a 0. There we go. So let's just, because my brain will hurt later. We're good. And this isn't running. Get in there, Wallaby. So we could just hit the infinite loop. Okay, Wallaby, stop. Let's go for this one, and I'll hit the debug on this here, just to make sure we don't do the badness. Yeah, how many layers should we go on for this? 4. Okay, so boom, and we did it, but then we failed. Okay. So that's just math being wrong. Let's stop up here. I probably multiplied the wrong things together. Okay, first let's see what layer we get to. Well, I mean, I've got a breakpoint on it. So 5 times 13. 5 times 13. I went one too far, I think. I'm not visualizing this. It really helps. 0, 1, 2, 3, 4. So I have 13 blocks. What rule is this? Oh, the following shrine can be built to complete the final layer. Okay, yeah, you placed all these. You need 3. So there are 5 at the bottom. You need 13 to go to the next. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, I think that's 13. I just don't know how to count. Interesting. So let's go through it each one. Yeah, let's go to each of these. So stop, retry. We have 13 blocks. Nope, stop that. Let's count at every stage how many we used. Okay, congratulations. We have 13 blocks. Blocks remaining. We place 1, so we have 12. Okay, we're about to push 3 more, right? Hey! Okay, show me. Okay, 3 more. Boom. Blocks remaining. Come on. 9. Then you're about to place 1, 2, 3, 4, 5 more. 7. 4, 5. Where'd you get the 7? Okay, so 1 goes up. 1 goes down. So we're placing 3s. 1, 2, 3, 4, 5, 6, 7. Okay, so 1 should be y, x minus 2 and x positive 2. So we got positive 2. We got negative 2, positive 2. Why is x negative 1? Are we placing... We found an existing block with an x that you're looking at. We should find it. We should be like, don't place there. But we're placing. It appears we're placing. Let me look at all my blocks. Do I have any negative 1, 1? Negative 1. Only y 1, so we're going up 1. So we have 1 at the top. 1, 2, 3, 4. And then, okay, so at this position, negative 1, 1. That's in midair. How'd you get out there? Supposed to go left, right, and up. How are you in space? Negative 1, 1. We have negative 1 here. We have a 1 here. My brain hates this problem. My brain really hates it. I need to visualize this thing, unfortunately. Okay, so I'm here. I look at all the blocks. I have 1 block. I look in 3 directions. Left, right, up. And with this block, I have these blocks. I look in 2 directions. Left, I find it. Up, I find it. Right, there's a block there. I can't find it. Here, I do left. I do up. I do right. Here, I do up, right, left. Okay, I need to go through each of them, unfortunately. Dag nabbit. Okay, let's do this. Okay, let's go through it. So we are looking in every direction. I could just go up to here at this point. I need to go there. Well, the L might be the wrong layer. Okay, so Looking at this one, did I find existing block? I didn't. I'm looking at -1, 0, so I am looking to place a 2 here. I'm gonna do it. I'm looking to place a 2 to my right. I'm gonna do it. I'm looking to place a 2 above my head. I'm gonna do it. Okay, let's see where we got here. So the L is the wrong layer. So I am trying to place layer 3. I'm looking at a layer 1 block, so I will ignore it. Good. Okay, now I'm in direction land. So I am looking to place this 3. I'm gonna do it. Good. I'm looking to place, well, I'm looking at 0, 0, and I see a block there. So I'm gonna do nothing. Good. Now I'm looking at -1, 1. Okay, so I'm at -1. Dang it, where am I? X, Y. So I am the X. I'm this 2 right here. And I am looking at -1. I see the duplication. I'm placing in 2 places already. Stop. Everyone stop. Const already placed. Next blocks. Find. Gonna steal the code. I was counting it double. I was even walking through it double, but I didn't put it in the code. Dang nabbit. Excuse me. I think that might be it. Dang it, 21:15. So we're closer. Let me get in there again. Let me skip straight to the end though. Okay, we're not hitting it in front of it, so maybe I can get this cooking again. Oh, I have all these other ones, right? I need to... No, not there. There. Okay, that's fine. We can continue like normal. We'll be cool. We'll fly. We'll survive. Okay, so we're adding 3. Congratulations. Now we're adding 5. 1, 2, 3, 4, 5. Good. Now we like 3. 3 times 7, right? Multiplying the number of blocks missing by the target width. Wait, how did 7 become that? Blocks with Y, 5. Target width. Wait, target. I get it. +2. So congratulations, you start with a 2 to handle the edge cases, and mathematically it looks like I could just use the top thing, but no one's got time for that. Okay, let's see if we luck out. Ooh, so it's a big computational thing. Probably because I should be using math to do this and not literally building a freaking pyramid. It also helps that I'm at next blocks equals, so I can do some tricks here. If I'm on the negative, I'll only look negative. If I'm on the positive, I'll only look positive. If I'm on the 0, I'll only look up. So next blocks, so I'm just gonna say congratulations, you're a let. And now next equals next blocks, right? And okay, here we go for directions. If x less than 0, and so we can just do 3 conditionals. If x less than 0, so const directions, I'm gonna get there. If x less than 0, directions dot push. No, not like that. If x greater than 0, directions dot push. So this is just keeping you going in the right direction. If x triple equals 0, directions dot push. You can only go up. Okay, I think that's what we want, so we can just drop directions right here. See if that works on my base case. Nope. Please stop, Jess. Please stop. Okay, so I thought that would work. That did not work. I was going for an efficiency thing there. Probably for the first one, right? So I need to fill in that second layer manually, which I can do. It's only 3 more blocks. One, -1, and then a +1. EZ. Is Jess back? Welcome back, buddy. Dang it, it's another infinite loop. I mean, where I'm at should be able to influence the possible directions I can go. I don't see big ideas. I guess that conditional never actually hits, where if next block's length is the thing or the other thing. Okay, let's just get on in here. Let's see if this is working. X equals 0. What? How'd you do that? How'd you do that? Oh, you're on this layer, right? Okay, you might not get any. Let's just zoom to next blocks. We don't add any. Dang it. Yeah, this is an infinite loop, alright. You got it. Okay, let me look at my directions. Left, right, up. Oh, blocks isn't a thing we're using anymore, is it? Or it is, but I've really goofed this one off. Let's save my computer a little bit. Don't we just see a pure math solution behind this? Okay, yeah, so it ain't working. Let's get in here. No, let's get over to here. Okay, so what are we looking for? We have one direction we can go up because our x is 0 and our y is, well, our y doesn't matter. So we can go up, and we're looking up, and x0 and y0, and x0. So this will go up, y plus y direction. And what's our current x? We're at 0, 0. Okay. Why are we looking at 0, 0? We shouldn't be looking at 0, 0. We should only be looking at the next layer out. There we go. Okay, that helps a little. It's not going to solve all our problems. Oh, what? What? We're not doing nothing now. I mean, oh, we're looking at layer 2. Let's bump it up to 3. I've advanced everything without advancing everything. This might be it. Okay, so let's just zoom to one of our end states. Gotta zoom further. It's not step through. I think I've solved this. Boom, we have 3 new blocks. Hello? 3 new blocks. What is going on with that? That was the weirdest thing. She kept giving me a bunch of 3s. What? What is going on now? Okay, so yeah, we got 3 new blocks. And these blocks are the next blocks. Yeah, this is all we need. We just need the edges. We don't need the interiors. Yeah, now we're going for layer 4. Come on. Yep, I guess we're on the right, so we're going that way, and we should find a block and place it. Okay, we're doing it. So we're placing 1. Yeah, so how many 4s do we place? 1, 2, 3, 4, 5, 6, 7. Yeah, we'll place 7 4s. 2, 3, 3. We did 3. We have 3 blocks. 3 2s. Dang it. Should be looking. Yes, for this one, we'll look at the other two. Okay, so when your your x is 0, you need to look in all directions, buddy. Because everyone's only looking horizontal, and you're only looking vertical. You need to do both. I get it, I get it. Directions push all of them. So, I mean, really, it's just an or on this. Okay, I'm feeling pretty good about this. Let's see if I don't crash my computer. 26, 30, 36. Now it's doing something else wrong. Okay. So we're adding 5 blocks. Dang it. You're at level 3. You're trying to place layer 3. Oh, you are placing 5, that's correct. Now you're at layer 4. 1, 2, 3, 4. My count's wrong. So it's 1, 2, 3, 4. There we go. Stop it. 12. So yeah, there's the 1 in the middle, and then these extra 3. That's what's going on. I should not be able to place layer 4. That's the problem. Okay, I'm at layer 4. This is good. And I'm counting all the ones with Y0, and I don't have any of that. So is it just next blocks dot length? Because I'm noticing that mathematical pattern. So I can cheat and just do that, and it will work for this one. And I hope it'll work for this one. Oh, come on, it's not that big of a pyramid. We're growing. Painful. Painful, painful, painful. Very, very painful. Okay, let me try and extract this. Oh, there we go. It's a number. Let's see if we're lucky. Did we logic our way through it? We did it. Layer thickness of 1. Calculate the thickness. Oh, no. Oh, no. Wait, why is 5 only need a few? What cursed math are you trying to teach us? Okay, so there's a way to calculate the layer thickness. I'm trying to use my eyes here. So the thickness of layer 2 is 3. And this is a 3-layer thick because there are 3 above the central. And the thickness of layer 3 is 4. 1, 2, 3, 4. Okay, I understand. 2 and then 1. Okay, this is only targeting the verticals. Okay, I'm really trying on this. I think I have to rethink this algorithmically. We care about the elevation, the highest elevation of every x. That's how this works. So over here, the highest elevation of -1 is 0, 1, 2. 0, 1, 2. Right, because that's the layering idea. Okay. Whew, I'm thinking on this one. How do they hit us with such fancy math? Okay, I think you just always add 1 to the outsides, and then you add thickness to every other one. Okay, I'm seeing the pattern. So you add 1. So you start with 1, and then you add however many, the layer of 2 to left and right and above. And then how many are layer 3? So I add 4 left, 4 right, and 4 straight above, and 4 to every one between. So let's look at this. 4 left, 4 right, 2 fours, sorry. Okay, I'm seeing the pattern. Now, the way you calculate how many blocks were needed for that layer is the width currently times the thickness plus 2. Okay, I think I'm following this along. Let me get my real number here just so I can delay my brain a little more. So solve quest 2, my example, which I saw some scary stuff going on here about them being like, well, in your case, it's this and that and the other. Showing only 3, 5 acolytes, and 50 available. Okay, so I need to take in like 3 whole parameters now. Jeez Louise. Quest 2, AC number, and what's our other thing? And 50 blocks are available. Wait. Priest, acolytes, and blocks. Okay, interesting. Total blocks. Sure, I'll type out everything, it doesn't matter. Okay. 3 priests of null pointer. Your notes is single number available. Okay, they changed what the heck my things are all meaning. So solve quest 2. 3 priests of null pointer, 5 acolytes, so my blocks is 50. I have 5 acolytes and 3 priests. What a weird start to a joke. Okay, so I don't even think I get to look at that previous one. It doesn't give me any value. Let's not visualize it. Let's just do the math, which, sorry. I think this part will remain in some degree. And maybe the inners of these bits. Okay, the inner of that one for sure. I don't think I'm doing this anymore. Or this anymore. Or this anymore. Or this anymore. So yeah, we're starting with 2. Let width equals 1. Right? So width equals 1. We're starting to place 2. And then we need to calculate thickness and then place it. So 1 times 3 mod 5. Okay, how did they do that? Calculation of layer thickness will be as follows. 3 times 3 mod 5. 4 times 3, 2 times 3. Okay, is that previous thickness multiplied by what? Null pointer modulo 5. Okay, I got it. Calc thickness. No, come on. And then basically I need priv number, and then come on, parentheses. And then it is, so it's always times 3, which is my number of priest modulo 5 accuracy. So it's something times something mod something else. So this is priv thickness times 3, which is priest modulo acolytes. And that's turning into an integer in the equation. I hope it will. I'm just going to assume it will. Okay, and then I guess so we need lat thickness equals 1, just for base casing. Const new width equals width 2, thickness equals calc thickness, which is the previous thickness. There we go. Okay, let's at least see if these are... I can't really see that. Okay, so now I need to multiply what I'm adding. So thickness times difference width is 3, right? So const new blocks equals thickness times new width. I feel like I'm missing something there, but I don't know what. Let's just try it out. What's the worst that could happen? We're not doing lengths anymore. Drop the length. Drop the length, not the other one. Delete. Okay, I feel like this is too simple and easy. So let's figure out where I went wrong. Let's put the breakpoint here. I mean, first let's run it. What's the worst that could happen? An infinite loop could happen, so let's not run it. Okay, so what is our thickness? Let's make sure that calculated right. Thickness is 3. Yes, and we add 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. Good. Okay, how many are remaining? Let's -1 on that, because that's how many we've placed. Let's get back in there and let's just send it. Let's send it. What's the worst that could happen? 24. 27. Son of that. 4, 5, 6, 7. I'm only off by a few. So that could just be... Yeah, okay, let's step through that. We'll figure it. So let's put it one in each, not every other line. Here we go. Yep, we're adding 3, or we're adding 9. We did it. Now we're adding 12. Look at my other things. My new width is 3. Dang it, no, it's supposed to be width equals width plus equal. Yeah, go back. There we go. It just kept getting taller, but not wider. Oh no. And it's just plus equal 2, not all this tomfoolery. I bet this is it. But put a breakpoint there. 27. Okay, we got it. Let's give it our real input, which... What's this number? 790. 3 null pointers, my notes. Great, so I have 3 arbitrary number parameters, which blocks, acolytes, PRs. Where'd I put the 3? Okay, it's the last one. Something, 790. And then what do I have here? My PR is... Oh no. It's working, but I'm using the math in the wrong places. Okay. So I said pre-acolytes was 105, and that was the 5. Oh boy, it's going to be a real fun to refactor. I have 2024 billion or something. What's the worst that could happen? A number that I'll have to recalculate in 5 minutes because it's wrong. Yeah. Okay, let's figure this out. I swapped some numbers, unfortunately. First, let's just copy this one so I can have record of it, of my wrongness. Stop copying that bit there. Okay, so we have, the first one should be my notes. Null pointer priest. No, so it's null pointers. ACOLYTS. Blocks available. Again, you're all our numbers. Just go with it. Blocks available. PR. What the heck do I call PR? Priest acolytes. So acolytes versus null pointers. And I just did those backwards. So 5 is the number of priest acolytes. 3 is the null pointers. Yep, I did it backward. Because the null pointers, that's the one being multiplied, the one being modded are the acolytes. There we go. Anything else I need to fix? drop that, put these in the right order. We have 50 blocks, something of those, something of those. How many null pointers do I have? Only 3. How many acolytes do I got? Only 5. Let's watch this work. 27. Okay, the fact that it's still working, slightly concerning. Okay, let's fix our things now. We have 1,111 priest acolytes, so that's the first number I give it. Null pointers. How many null pointers do I got? It's my notes. Okay, I have 700 null pointers. 790. How many acolytes do I got? I got this many acolytes. And how many blocks do I got? This many blocks. Now, if this doesn't work, it means my math is wrong. And I already don't like my math, so I'd rather it work. I have a few more minutes, though. I do. Okay. I mean, it still works for this thing, right? Okay, good. I have something going. I'm looking, I'm just trying to pattern recognize what I messed up. Thickness of 1, is that a concern? It's just 1 times the width. 3, 5, 7, 9. Yeah, times 1, because you're just adding to the top. I feel like this is going to be it. Wait, is this the same number I had last time? Because that will tell me if I'm wrong. Uh-oh. Uh-oh. Final structural width is 9 blocks. Dang it, it's still not working, but it's working for my example. This is the nightmare. Blocks needed for completing each layer. Maybe these calculations are wrong. Let's output console log new blocks. See if those are outputting in the correct order. 9, 20, 14, 9. Then 5. You didn't. 1, 9, 5. Okay, so they're doing it a little differently. Maybe I should just go the next one, the one I'm in deficit, go back. I think this would give me the number. Last one, rather. Yeah, 9 through 14, 9. 1, 9, 2014. There we go. So that was outputting. My eyes just 9, 20, 14, 9. Yeah, they are correct. Boy, my eyes hate me. 9, 20, 14, 9 is 53. You need 3 more. The final is width. So 3 times 9. Dang it. Dang it, dang it, dang it. I am also doing a weird calculation for this. So the final structure is width. So I'll just width return width minus 2. Because I'm doing a weird way to do this, and maybe that's the problem. So yeah, the current width, which was the previous one before I added 2 to it. Oh, sad little buddy. Times the amount I need, which is this. Same math for this in the end. 21, 27. Oh, whoops. Is it 3 times 9? I just off. Do I need not to do that? Because I'm terminating earlier than they are. Sure, will you give me a better number now? It did. I have no idea why. Let's go with it. It's also smaller. I forgot there's part 3. Jeez. Okay. Great, it's hollow. Oh, why you people are crazy? I gotta feel like I gotta do some stuff. Okay. What eternation? Oh my, I gotta read. There's 2 pages of reading here. Come on. Layer thickness of 1. Okay, so we changed the calculation of the thickness. How many bottom bricks in each column should be left as empty space? The blocks forming the upper frame cannot be removed to prevent the structure from collapsing. Adjacent blocks connect to the side planes, not diagonally. Example. So everything has to be touching. How many should be left as empty in a specific column? Number, the number, the number. Okay, so there's a math process. Platinum. Okay. Okay. Well, it feels like we just changed the entire problem. But let's go with this. So round 3. Let's figure out. So assuming 2 high priests, 5 acolytes, and 160 blocks. And then let's just copy the real one, because I know I'm going to have fun with that later. So this many that. How many high priest acolytes? 10. How many, whatchamacallit, blocks? A kabillion. Love it. Okay, check that real quick. I haven't even looked at this thing. Jeez. Okay. So I have my numbers in place. Let's put them in the function definition. Quest 3. Okay, what are they? We have the first one. Acolytes and blocks available. Jeez Louise. Okay, so multiply the thickness of the previous by the number of high priests. High priest. Take the remainder, dividing the result by the number of current acolytes. 10. Okay, I'm already doing that. Add the number of current high priests to the result. Let me print these, see all these for my order of operations. Okay, so that's my new thing. Okay, cost empty blocks for column. I suppose I'll take the column height. Height, okay. Multiply by current width. Okay, let's just do this. Return high priest multiplied by width multiplied by call height modulo by acolytes. Now you know how many bottom bricks should be left empty. Sure. Blocks are needed for buildings shy of that size. Only calculate the number of blocks needed. Okay. I did some functions. I'm lost a little bit. I'm a little lost. similarly to, and then 100 blocks available. Calculation of layer thickness is doing the thing. Okay. Look as follows. Jeez. Column heights 1, 8, 17, 25, 31. Right. So you made a pyramid, but you're telling me the column heights iteratively. Okay, I see it. So total layers, so 5 layers. Okay, I'm not preserving heights in any of my calculations, unfortunately. I can do that. Oh, you're really hitting us with the math this time, buddy. How many platinum blocks do you need to do the thing with this new design? Whew. Another one where I feel like I'm at my limit here. Okay, back to the top. The blocks forming the upper frame cannot be removed to prevent from collapsing. So I still think I build it. Then once I build it, I have to do all this other stuff. My thickness calculations are just different, right? So I don't know. This one's got me. 715. I can't even tell what I'm supposed to have for this example. Requires 162. Right? Okay, so 162 is what I'm supposed to be returning here. Below you can find a few more examples. Let's try how many platinum bugs from the shrine with a given number of layers. Okay. And then removal. So for every layer, let me try to follow this through. As I add them, do I also just try to reclaim them? Will that be the way this mathematically jingles out? Needed for next layer, right? So I mean we have. I guess we'll start to see if our layer thickness is working good. Layer and thickness, right? Let's start with that. 4, 5, 2, 6, 4, 5. Nope. So let's at least start on that. So yeah, we're on layer 2. We're calculating its thickness. 1 times 2 mod 5 plus 5. 1 times 2 is mod 5 plus 5. 1 times 2 mod 5 plus 5. These two should be the same number. 1 times 2, that is number of high priest. Mod 5 plus 5. Acolytes. I said priest when there should have been acolytes. Okay, at least this might be a good 7986. 7986. Okay, I got that working. We're actually not too far off. So, what I need to do now. It's a weird thing. How many do they need to. What? Needed for next layer. So, like, I'm no longer returning this. Am I returning plus blocks available? 177, supposed to be 162. I'm not doing any of the cleanup, so I don't know why I'm expecting that to work anyway. Okay, 5 layered shrine requires 162. Oh, you also got my the other ones. That's cool. Alright, it requires 162. So we have the new layers, but we're just using all of them. Right? Layer 2, 3, 4, 5. 7986. What's this width thing? What's this doing? 1357. Oh, those are my widths. Yeah, let's log them too so I can stay on track. Oh, I've literally made the table. 273 395 487 and 569. At least that part's going well. And yeah, calculating these column heights, it's what I need to be doing, at least it appears, but I'm not. So, is there a derivative way of doing this? So it's -1 minus 7. Hold on. 23 minus 14. 9. Okay, so it's always thickness of last layer. Those are the heights of the columns. Oof. Okay, I'm seeing the math here. So I don't need to track the column heights. I just need to track all the thicknesses, and with the thickness I can iterate from current layer to 1 to get the column heights. If I keep track of my current height, and then I just double that for the other side. Okay, so I just need a height. Let height equals 1. Then what I do is I always add to my current height the thickness of the next layer, right? So less equal thickness. So yeah, let's add another one. Height, we're just console logging all the things today. 8, 17, 35, 31. Boom, I got it. So I have the height. First and last 6, there, the upper frame of the shrine. Height of 14. Okay, so this is it. So once I reach, when do I stop? I stop when I run out of blocks, right? But when do I, how did I know to get to 5 layers? I need to find that end condition that I can do all this, because I can't do this every time because this is a calculation. So the 15 machine left is empty. Constructing a full 5-layered shrine requires. Okay, so if I go to the thing and I'm like, how many do I need for this? How many do I need for this? So I go to every layer and I do the calculation. Okay, that's going to be expensive. So I have to do that calculation every time. Let's see if I can do that. Cost needed for layer. Right, and I don't modify it, I just do it. With height, I don't have the previous thicknesses. Can I calculate them? No. Well, I need the previous ones to calculate them, so I just need to keep track of them, I feel like. But oh, math. How much would that hurt to store? Let's just store it. Yeah, so we drop that. Thickness is push the new one. Congratulations. Alright, so we'll just keep doing that. I don't think nothing's going to change this visually because we're not doing anything yet. But now, so like say here we were at this height. We should be able to calculate the number of blocks needed by going at myself, my left, well, and then my right, and then my right for all the ones needed. So how do I know? It's until I reach the 1, right? So I guess I'll start with the column heights. So let t equals, I guess we're just going for height while t layer truth value. We're going to remove the thickness of the last layer. T. Actually, we can just iterate through all the thicknesses for cost. Thicknesses. Thicknesses. And is that the right order? No, it's not. I need to go largest to smallest, so let's throw that in there. For the reverse. There we go. T minus equals thick. T, don't know why you're so angry. Oh, I put the word think, that's why it's angry. Okay, let's see how that looks. So 10810. Yes, I need to not look at the one. Reverse. So I'm going from largest to smallest. Slice 0, -1. Do not look at the last one. So from 7 to 1. Okay, let's look at the last one. 25. So what the heck? 17. 8. 24. What am I looking at? Yeah, so I'll go from 31. And how do I get to 30? I'll subtract 1. What? Where did that go? I thought I had the pattern. It was with my eyes. I had a pattern there. 31, 25, 17, 8. 31. No, I didn't. I don't have no pattern. So I'm logging everything else right. 5, 6, 9. The height of the layer. So it's 1 plus 7 plus 9. 8 and 8, 16. Yep. Plus 8. Then 17 plus 8. I think that's going to take me there. It's 25 and 31. Oh, I'm getting the previous heights for mine, not my 1 over. Ooh, okay, so that calculation is going to be a little harder. Let me put that log back and look at it with my eyes. Come on, look with eyes. Move, mouse, move. Okay, let's look at it now. 25, 17, 8. 25. So yeah, it's going up and not to the right. So what I need to do that? Do I need to remove... So this is -1, but I can't see that. And then it's -7. That's -9. It's -8. Okay, I can see those numbers at here, but... So it's... the layer plus 1 minus... I can see it. I just... Jeez, this is tough. I'm making it tough, let's say that. Entries. Okay, so we have this. So what we need to do is we need to get the first layer. And how do I know it's the first one? Because I am on 0 and it is on 0. So... which means all these things... what I'm doing here isn't going anywhere in the direction I want. So I want to iterate through the number of thicknesses we have and just keep removing them in the correct order. So it's the non-reversed order. I don't even think you're slicing it. I think you're just going through it. Did I really overcomplicate it that much? 30, 23, 14. What am I am losing it. I do want to skip the end though. Slice 0, -1. There we go. So now we have the heights for all of them. We have the height for our current one. We can do the calculation. So what needed for this height 0, I guess, and then, well, technically we do the first calculation on ourselves. So an empty block for column. What's this doing? What? But how many? That's how many I'm empty, not how many. Oh. So it's the amount that I've placed down minus all the empty ones. Dang it. Let to empty equals empty block for column height equals height. And then I guess I'm just adding to empty plus equal empty block for column T times 2 because I'm doing it left on right. Okay, I'm hoping to see this number somewhere showing up. 9, 0, 0, 20. That makes no sense that this layer I empty out 9. Okay, moon blah block from 5. 5 layered shrine, right? What layer am I on? Two, 4, column of height 30 stays untouched. I don't know how that happened. Okay, I just need a log for each of these now. Get me in there. It's 5 lines up. Let's see if this calculation is at least right. Okay, so if you're at a height of 17, so I'm just going to roll the ones I can see. Column height of 31, you remove 3. Yeah, this being called the same thing a billion times. Not a good sign. Oh, I'm not modifying T anymore. Don't know how I got rid of that. Let's put it back. Crazy idea. 21? Let's see. Okay, so for height of 31, 3 I've removed. For height of 30, untouched. For height of 23, remove 4, 5, 14, do that. The first and last of a height of 6 is they are part of the upper frame of the shrine. Who said that? Why? Who says you two get skipped on? The first and last columns. Okay, so it's the fact that they are first or last that keeps them in. So do I just -2 that to be like, hey, let's don't consider the first and last, fellas. 14. My next would be 6, but I don't look at him because he's the first and the last. Okay, so now I'm removing things 2, 4, 3. So I have that. That's 6, 7, 8. That's 9. What? 5, 6, 7, 8, 9. Oh, it's both sides. 15. Okay, 15 should be left as empty. So constructing a 5 requires 162, which means the king needs to purchase an additional 2 blocks. Okay, I have that number. How did I get 162? Can I tell me how many blocks I needed for this layer? We have the ones that are empty. Let me just log some things. 2 empty. Yeah, let's get some things. A layer to empty, new blocks. Let's drop some of these. I'm seeing it, but I'm not. So layer 5, 2 empty. We need 54 new blocks. I need to add how many we've spent, which is blocks remaining minus blocks available. So far, so it's math. Let's just add a 1. Spent equals 1. You spent 1. And every time we spend blocks. There we go. I have done too much math for this problem already. Spent 123. Full 5-layered shrine requires 162. How did you get there, buddy? Oh, so do I have to add the new blocks and minus the 2 empty? Plus new blocks minus 2 empty. Doesn't seem crazy. 162. Okay, I did it. What am I supposed to do with this number again? How many platinum blocks at minimum to ensure the shrine design can be completed? I have this. Oh, so I have this many blocks. I'm like, hey, how many more do I need? So do I return it when I run out? If new blocks is greater than blocks remaining. Well, sure, yeah, new blocks is this, but I'm technically gonna minus this with 2 empty. Which means I don't need to do that. Which means that log should still work. Nope, I goofed it, because that's how many you add to the thing. Put that back. Okay, I've lost it again. Let's try to get it back. Because this is an isolated calculation. Okay, I am stopping here, so it's successfully stopping on this one. Kinda. Well, it was. Then I broke it. So do I just return this now? 162 is what I'm supposed to return. Sure. I'm doing a lot of logging, I just realized. It's only 1 for each. Okay, it's a lot of logging. How many layers do they make? 4096. They do a lot of logging. And the first one was already a long log. So let me go QTS this. There we go. I don't think my terminal's in the right folder, or not in a folder at all. Okay, so that's gonna run. Oh, I thought I got rid of it. Where is it at? Oh, this one. Yeah, that would kill me. I was gonna eat and be alive. Okay, it's not an instant calculation. It's doing lots of thinking. More thinking than it should need to do, because there's a pattern here, and I am recalculating this for every layer we touch. Because I need to calculate how many to remove, or how many... I mean, do I need that there? I only need to empty here, because it's not going into this calculation, which I feel like it should be, but it's not. So let's put that into here. I risk getting the wrong number. Yeah, that's a risk. Yeah. Oh, look, I get a whole minute this time. That's nice. Okay, the problem is that the number of blocks I made is not new blocks. It's new blocks minus however many I would empty at that layer. I haven't really used this example list, but probably should. So they've given us this math here for calculating the ones to remove. I followed it. So should I not follow it? Try and preserve the previous empties? Yeah, column of height of 30 stay untouched, which that literally makes no sense according to visualization. It means you're just maximum height. Like you're just a pure vertical column. I'm getting mathed out here. Okay, so I'm doing all of this. I'm not seeing it. Huh. I'm not seeing it. Whew. It's a sticky one here. I don't see it. Ah, boy. Yeah, I think this one is burned me out here a little. You know what? This might be one of the first ones I do not finish in the moment. This tells me nothing. Yeah, they're getting tougher. Guess we're building this structure. Empty space in a specific column. Okay, let me look at one of them, for example, 14, 23, 31. Columns of height of 14, 2 blocks are removed. I don't see it. I can't even visualize it because this is a height of 3, 4, 5. Height of 7, and we're removing 2. You're telling me a height of double this? Well, we're still moving 2? 2 blocks are removed. 15 blocks to be left as empty. Yep, I did that. So the thing is, I think I have this working. I probably should have just been running it though. So let's get that runtime going. And let's just log blocks remaining so I can see how they're progressing. Okay, it's progressing. But that's a lot to progress through. If layer modulo 1. Yeah, let's just go for that. I'll drop a couple zeros to keep my life looking at it. Okay. I think this is sufficient. It's getting slower. Should we be consuming more blocks? Okay, so that last one was like 100. 140. Okay, it is consuming more. Okay, what memory are we dealing with here? We're adding to thicknesses, so this is going to be our memory constraint. How do I calculate the previous thickness? If I just keep the previous one, can I use the previous to calculate the previous and just make this computational, not memory? Though at this rate, it's okay, it's still chunking away. I'm just going to let it run. So boom, I have a thickness of 6. How do I get back to 8? So I got to 7 by multiplying and modulosing. Yeah, use the previous to make the next. So I have a 6. I want to turn it into an 8. I have a 5. I don't think that can go backwards. We're getting not too far off. Huh. Hope I have my edge case. My end case, rather. Yeah. Is this circular in some way? I mean, it can't be higher than a certain value, right? Like, you can't be higher than something. I'm just really hoping this brute force gets me in there. I don't know what I submitted last time. It's not correct. At minimum, shrine design. Okay, but what's your shrine design? Like, you've given me this many blocks. The width doesn't matter. Calculate the number of blocks to fully complete the shrine. Well, with a layer height of whatever heck that was, it was this many. Which I'm not logging the layer height, of course. Console log layer. So I have this. Should I calculate the previous one? I mean, I can do the previous one. Actually, I can't do the previous one. It's gone. Okay, let's add another if here just before this to say, hey, if... I'm checking if I'm second to last, basically. Okay, so I have all the information I need. I subtract 2 from width. I subtract the last thicknesses from height. And I subtract new blocks from spent. Next equals here, and we're still returning next because that's what works for the other one. Minus equal 2 height minus equal thicknesses at -1. Now what's the next one? Spent is equal new blocks, which to calculate the previous one is thicknesses at -2 times the previous width, which is already width. Okay, now that I have all these, I can calculate how many to empty. To empty 2, sure. So I have that. And calculate the next one. I calculate NXT, which is how many I've spent, which I have that one. The number of new blocks, which I can do with this right here. New blocks 2. And to empty, which I have to empty 2. So let's try it. Oh, no, not construct trivia. Console log. So NXT is spent plus new blocks 2 minus 2 empty 2. Guess as good as mine. Calculations are going to be the exact same length though. What the heck are you doing? What in tarnation? Gonna ignore that. But yeah. I think this might be the first of many that fully stumped me. Especially since I just killed my terminal or something. Yeah, if I figure it out, or if I have an epiphany, I will come back. If this solves it, I'll also restart it, but that is what I'm going to call it for today. Hopefully it's just a one-off where I can't see the cool math, but time will tell. It finished running. I'm going to try to put the previous number in, see if it works. Nope. Okay. I'll come back to it with an idea at some point. I wonder where that number came from. Oh, it's layer number. Cool. Hello, hello, hello. Today I will be refactoring my Everybody Codes Quest 8 solution. Okay, yeah, this is the one that I wasn't able to fully resolve in the moment. That part 3 was a toughie. Came back to it and realized, oh, I just need to do the math a little differently, and they actually bumped the number from, then bumped it down a number of zeros of magnitude. So first, I suppose I'm going to make sure that the existing tests work. Let's see, part 1 still works. That opened up really big. And we're off to a great start. I'm going to run on the example for part 2. Oof, okay. Okay, part 1 finished. There we go. Part 2 and part 3, I imagine, is the one that will attempt to but then fail. Let's say I don't have the correct number in here, so let me go and grab that. This number. Oop, and the third is this number. Oh, up here is the message about that brick count reduction. And when I actually did the solving, because I was worried about computation time, because Jest is slower than normal, we have this, which is the change I needed for part 3, which goes right there. Or nope. Okay, I guess these are some bits I didn't copy back here. We'll do that now. Just getting this finished. There we go. I'll leave that in comment land. Sure. Okay, I think that might be it. Oh, my test is still running for part 2. Jeez. Yeah, so lots of room for optimization here, obviously. Okay, let's hit that with a reload, because that's taken a bit too long for my liking. And let's target, so we know part 1 is good. The part 2 example, that one should go quicker, as expected. Now part 2 notes, oh, okay, things are just working really fast now, I love it. With that part 1 example, or part 1 notes rather. What's in there? I guess this number's a big one. Right, because I believe part 1 and 2 transformed what they asked a little bit from 3. Yeah. Okay, there we go. Now part 3. Let's see if the example takes. Whoops. The example. Additional 2 blocks. Yep, that was my thing. I was like, where's my 162? It was the 2 we were supposed to be answering with. So that will work. And I know the part 3 one will work. Don't know how long it'll take though. Let's find out while I explain what they're actually going through. So, the explanation. So for the part 1, we're basically tasked with a number of blocks and told to build a pyramid of this shape, where it's kind of like an onion, where each additional layer is an additional layer. But the trick is that you can only build full layers, so eventually you're going to get to a point where you don't have enough blocks to build the next layer. So if 13 blocks, we can build this many, but we can't add the 3 remaining for what would be layer 4. So the answer is to take how many you need to build that last layer and multiply it by the width of the pyramid, which just so happens to be, I'd say happens to, it's a mathematical thing probably, the number of blocks that the next layer actually needed. So you can see the width here was 1, 2, 3, 4, 5, 6, 7, and the number of blocks for layer 4 is 7. So it's just a coincidence there that can be reused mathematically. So that was part 1. Part 2, I believe, was the same thing, but we had a thickness that was determined by 2 other variables, and we're asked to do the same thing. Calculate how many additional blocks you need for that last layer, multiply by the width. The trick is that there are now 3 inputs. There's the number of null pointer priest, the number of priest acolytes, and number of blocks available. And the, which is it? The priest and the number of acolytes is used with this mathematical formula to determine the thickness of a layer. All that to say you get to build this cool structure like this. And the thickness is vertical thickness, not horizontal thickness. So we can think of it like snow, where it's like, okay, it snowed 1 today, and then for every additional layer, being increase the width by 2, 1 in each direction, and vertically, the width of this layer was 3. So it adds 3 to the new edges, and adds 3 to any existing one, which we only have 1 in the middle. Thickness 3. Next one, thickness was 4. So add 4 to the far left, add 4 to the far right, and add 4 to every one in the middle. So 1, 3, 2, 3, 3, 3, 4, 3. Same here. And that continues on until you consume all of your blocks, and then you calculate how many extra blocks you need for that layer, do some other stuff. The last bit is the toughy one, where they decided to make the shape hollow. And it wasn't just, oh, the shape is now hollow. It is, there's a mathematical algorithm to determine how many blocks you remove from a individual column based on that column's height and all those other priests and acolytes and other numbers like that. Yeah, this is where they start representing things differently, where they're like, okay, first, the individual column has a height of 1, and then we have a layer of 7 thick, so the edges get added to 7, and the middle one is 1 plus 7, layer of 9, layer of 8, layer of 6. These are the outer edges, so you can kind of think of this upside down. And then the column height just continues to add on. The cool formula they defined with the number of blocks that should be left as empty. You do some stuff with the number of priests, the number of acolytes, the height of the column, and you get a number. There's another mod in here. They walk through the example here. So for this column with a height of 14, you remove 2 blocks. If you were to create an ASCII representation of this, it would not make this much sense, but you have to kind of disbelieve what's going on right now and just visualize it with the math instead. For example, column of height 30, it doesn't get any blocks removed, so it's basically a pillar. Don't worry about it. Don't let physics ruin the math. And then they provide examples for other things for you to check your numbers on. Now the trick here, and that's what I missed before, you're not returning a multiplication, you're not returning the number of blocks needed for that layer, you are returning the number of blocks that you are missing in order to complete that layer. So for example, we're given 160 blocks for this tiny example. You do not answer with 162. You answer that you are missing 2. That's what I did not catch. And then yeah, how many platinum blocks at minimum should the king provide to ensure the shrine design is completed? Again, that's the part that caught me off of like, oh, well, you need 162 to complete it. And it's like, no. It's like, how many additional platinum blocks? 2. I believe that is it. And we have computationally died, apparently. But it is functional, so this is why we have our examples to run on. They are fast running, and what we will be using do our part 1. Okay, part 1 notes the problem. I'm going to put a dot skip on it because these are effectively outside the realms of little chest extension compatibility. I'll run them at the end, but we'll skip them now. Oh, 15 seconds. That's not bad. Okay, so we got a lot of code here. Let's go through one. So previously I was just keeping all of them in memory. Now I'm going to keep the edges. So I start off by setting up the second layer. So my code doesn't work for any layers less than 2. By what I mean by that is my pyramid starts off like this. Specifically, I'm only keeping track of the outermost blocks. So the inner ones, I just don't keep track of in memory. Not because it's hollow, but because I don't need them. I then iterate through all of them. If it's not the layer I'm looking to calculate, which we don't need that anymore, because we don't need that. Which means we don't need the layer at all. So we just need to be a layer plus 1. Which means we don't need this at all. We're just tracking the next layer. Nice. Sorry, I was looking to do that. And what we're doing now is we are calculating what directions we can go from this position. So there are 3 candidates. Let's take the 2s, for example. If you have a block here, then the potential outcomes you should look to the left, and you should look, hold on. Yeah, you should look to the left. And I do this based on what your x coordinate is. So x0, x minus 1, x1. So if you are to the left of center, then you can make blocks to your left, which continues to work. If you are to the right of center, you make blocks to your right. If you are center itself, you make a block to your right, your left, and above you. So let's take 3 for example. This one makes one to its left, this one makes one to its left, to its right, and this one expands to its right, up, and center. That's what this logic is, to go in all those directions. And I don't even think we need the existing or the already placed. This was from before when I had all of them in memory. Now it's basically guaranteed that where I'm looking has never been placed before. Just like that. Which means we can inline some of this. Like so. That still works like a charm. Which means we don't really need to calculate directions. We can just straight push into the next blocks. I like it. And this is checking. Okay, so this is our end state effectively of. Well, I did not mean to drag that. This is like if we need more than we have remaining, then we have reached the layer that we cannot complete. Math time. Otherwise, we got more blocks to spare. Let's keep it moving. So what I want to do here is, don't think I need this layer. Drop the layer. There we go. I want to directly push to next blocks like this. So x, so it's an object x is plus, and then it's y plus. Go to the end, turn this into an object. There we go. Yeah, we don't need to create an array of directions and then use those to create blocks. Just create the blocks you need inline right there. This OR is to make sure that when we're at the top, or like the center one, we're creating left, right, and up. Which I'm going to move to the front because that looks a little better. I like it. Let me do that. Okay, I got one, yeah, I think I'll leave this here. Trying to think to be a little bit more efficient. So needed for next layer, there we go, next blocks. So we have blocks and we have next blocks. I'm wondering if we can just reuse the same array. If it's even worth it. I don't think it's not worth it. Yeah, I think we're good here. This if-else feels like it can be improved. So at least separate them with a new line. So basically this is we fail. So let's do, we can keep going. And drop a continue in there. And then just drop the rest of these like this. Nope, not there, like that. There we go, I like that a little better. Okay, I'm feeling pretty good for part 1 there. I believe the trick of 2 is that there's just now a thickness and we're dealing with pure math. So I'm doing a simulation here. I wonder if I can upgrade part 1 to use pure math. So in theory, I can just use part 2's code, but with a kind of set and thickness of 1. Or an always thickness of 1. Let's see if I can do that. Notes. Oh yeah, all this other stuff. Congratulations, your thickness is 1. Not 2, 1. Blocks available. How did I do that before? It's just notes minus 4. Blocks available equals notes. I'm curious if that works. Boom, yep. So as part of part 2, I found the math way of doing this. and I went with that, which is what I will be doing here. As cool as the simulation is, we don't need it. Why is this in parentheses? I mean, there's a reason. Don't need it anymore. Right. So I think 3 is the difference. So let's say function, and then I'll explain how part 2's math works shortly. So what are we doing? I'm trying to think of a function name that's generic enough. Do the thing. That's all we got. And then right here, this is the thing with blocks available, number, and now 1 and 2 both do a calculation of thickness. Previous thickness, oh boy, it's acolytes. I think we'll have this in here. Thickness takes in a number. You are supposed to return number, right? And we'll default this to, we won't default to nothing. Now we'll let the colors do that. Boop, boop, boop. Love it. So now solve 1 is return, do the, not do it, report it. Do the thing, notes 1. Solve 2 is the same thing, but calculate thickness is this. Blocks available. I love it. So 1 and 2 should both be happy that it is. Okay. Got a lot of things that should be numbers here. Now 3. Is it basically the same thing with a calculate hollow and blocks to remove for column? And by default, these other ones are zeros. I think so. Let's go for it. What's the worst that could happen? So you have calc thickness already up there. Yeah, calc thickness, stop looking at that. Only to recopy that for 3. For column. There we go. Okay. So for part 3, it's doing this. Well, I paste it up here because I just lost it. The name does that. There we go. So part 1, do not empty anything. Okay, let's see if that works still. No. Okay, so because we're returning a different thing, we're not returning the math times the math, we're returning the other thing. So do the thing now needs to return a couple different bits. I don't need to keep that in my clipboard. I do need to go back to what it did have and get that result out. What did we have before? We had width times needed for next layer. So that math right there, put it all back. Okay, so we need to return width needed for next layer. There. Next layer, and then we just return width times needed for next layer. Right, yeah, we just do that. Now the trick is we need NXT and blocks available. Is that basically needed for next layer? I'm not sure. Let's drop this. Let's see if part 1 can do that. New. I think we're going 1 back. So width needs to be width plus 2. And then blocks remaining got changed? No, it didn't. Okay, there we go. Because it's 2 states. There's where I'm at and where I need to be. Need for next layer. So I have that working for 1. I can do the same thing for 2, which I will do right now. Now my 3 usage is what's got me concerned. Because 3 needs NXT minus blocks available, which, sure, I can do that. What is that? Needed for next layer, which is NXT minus blocks available. Let me just bring 3 into the equation. And then I'll destructure that from its thing. Right, let me figure out the math for this, which is defined right here. It's right here, actually. Those are the lines. And then height goes here. And then something is wrong with my thickness calculation. I think variable names might have changed. No, the actual things we were doing changed. There we go. Cannot find column height because I called it height here. Okay, let's see if 3... Oh, I didn't mean to drag that open. Let's see if 3 is still satisfied. No, width before initialization. Oh no, so I need the width in this one. Good thing to know. Let's update that function to also give it a width. Okay. I can do that. It was something just being ripped out of scope, but we will do better. Nice. Boom. Works perfectly as expected. Okay, so we have this. We're just returning whatever's in 3 here. Let's start filling with those return values and then trying to refactor how we get there. So we just need to look here and then we can start extrapolating. What do you want? Watch. There we go. So we want the number 2. So what do we have blocks remaining? 37, 54. So NXT is 162. That's how much the new layer is. Blocks 2. Let's start trimming the stuff we're not physically using. To empty to T. Think we're not using any of this. Height spent. We're not using any of that. Width minus 2. We literally unused that here, so let's not do it. Layer, log. Yeah, this is what we use right here. Spent plus new minus however many we need to empty. My paranoia tells me to make sure I didn't break anything just now. Good, nothing's broken. Woo! Let's get back in there. So I need to spit out the number 2. So how many did I just spend? 123, 54, 15. So I think this number, so NXT, total needed for spent new blocks to empty. Like I want to expose the generalized information and let these solvers do their thing. And I don't want to just spit them like calculate part 1 answer, part 2 answer, part 3 answer. So width is that much needed for next layer. So it's needed for next layer, yes. I'm trying to think of a better word for this. Deficit or blocks missing. There we go. Blocks missing. It's like we're missing that many blocks. We have last layer, this layer. Blocks. Yeah, 37, 54. Blocks. And let's see. Blocks to hollow. I don't know. Let's try to rename this one. Blocks. This layer right here. There we go. So I like that one better. This layer blocks. Blocks available. Maybe expose that one too. So if we expose total blocks to this layer, and this layer blocks, and we also expose blocks available, we can calculate that for 3. And blocks missing. Yeah, I think I like exposing that one better. Okay, which means, well, width is width. Drop that one. So the 2 weird ones. Oh. I'm going to rename new blocks to that too. So we have all the information we need to do the math. And we are actually exposing one of the things of the math, but we're exposing it in a way that's useful. So 3 is return dot that. Yeah, stop the debugger. I think the rest of these will continue to work. Nope. Quest 3 is returning the 2, which was supposed to be minus blocks available. So I'm supposed to do 2 things there. I think I have this backwards. Adu. And we back. Okay. Let's drop these in favor of its actual name. Cool new name. Drop these for empty structure again. I love it. Ooh, blocks available. So we already have blocks available. We don't need this number. Nice. Nice. Which means you don't need to return it. Loving it. Do we need this layer's blocks? We don't. Blocks missing. We need that. We need the width. Total blocks to this layer. Okay, I think we have our generic function built that does what we want it to do. Having these 2 functions passed in, we need them to that degree of customizability. I'm having 2 of them both. I'm thinking of an object called calculators, one for thickness, one for empty blocks for column. I think this is fine though. Let's worry about the other stuff. So thicknesses, we need to keep track of all of these to calculate our empty blocks. For every one, we add 2 to the width. We add a new thickness, which is taking the last one and adding to it. We add to our height. What is this? What's T for? I keep removing thicknesses from it. Okay, so this is the trick I'm using to calculate all empty blocks to remove, or to empty. Current height, that's what's technically happening, and then this is what we're calculating. Remove a thickness for every thickness but the last two. And we do it because one on each side, one in the middle. Yep, I like that. And then instead of new blocks, needed this layer. Let's not trim out in words. For this layer. There we go. I'm going to invert this like I did in my 2. Drop those. Drop those. I like it. Yeah, we have blocks remaining and spent. We don't need both of these. We can optimize that to a single variable. Let's make sure I didn't break everything. There we go. Still working. So spent, blocks remaining. I mean, I like calculating spent. So let's just do cost spent. And this is where we would calculate it from blocks available and blocks remaining. So it's the bigger one minus the smaller one. So if we have 100 and we have 98 remaining, and we've spent 2. It's like that. It feels like it. I think I just said the words wrong. Okay, it works still. We're not going to question it. I said it wrong. I wrote it right. Okay, we have width. We have height. We need height. Is height not just calculated from the sum of all the thicknesses? Well, plus 1 maybe. I'm going to look about that. So height equals thicknesses reduce A plus B. Maybe we start at 1, maybe we don't. I don't know. Let's not make it a variable. See if we get lucky. Fine, we'll make it a variable that's calculated here. Oh, lucky me. Yeah, we don't need that. It's the sum of all thicknesses. Okay, this is working. The width, it's just incrementing by 2. So I think we can derive this from the layer. So with layers 2, cost width equals, well, it's 1, so it's 3. Layer plus 2. Is that how we're doing this? No. So we add 2 every time. Yeah, we don't add 2. So let's walk through layer 2 with 3, layer 3 with 5, layer 4 with 7. There's some kind of pattern here. If I keep writing it, I'll see it. 5, so 2 plus 1, 3 plus 2, 4 plus 3, 5 plus 4. So it's layer plus layer minus 1. Layer plus layer minus 1. I think that's it. Boom, there we go. Less things, less state. We love it. Blocks remaining. So it's how many I've spent, basically. Or it's how many is remaining, right? We need track one of these. And that is literally from needed this layer. So yeah, I don't think we can get rid of this one. Okay. Calculate thickness. Add up them all to get to your height. I think this is the most computational, painful thing at this moment. Going through all of them and recalculating how many empty blocks are needed. But I think we've done good to clean this up, at least logically. Total blocks to this layer. Do we need this? We need it for you. Can I just give you numbers and you'll be happy? I'm fine keeping you at this. Too empty. Let's rename that. What do we call this? To hollow out. Left is empty space. Blocks left as empty space. Okay, I'm using the word blocks a lot. I don't like this. Available. Remaining. Left as empty space. Needed for this layer. Total to this layer. Missing. I've literally already renamed you. Why you do be like this? Okay, I think some good is here. Oh yeah, that's what's happening. It's keeping the names of the destructured. There we go. I like this a lot more. What are we building? A pyramid or what is this? What are y'all calling this? Okay, here we go. Plan shrine building. Sure, it's a good enough name for me. Make sure this all still works. Great, didn't break nothing. I think pretty happy with it. My parameter ordering got a little crazy there, I remember. See, I know we still have this bit here where we're doing a lot of calculations. Okay, so we have all this going on. I'm wondering... So we're doing a thing, and then we're doing a thing, and then we're doing a thing. Yeah, it's hard to see where to optimize, because there's no real measurements here. It's all guts. So let's unskip some tests. Make sure I didn't break nothing. I'm confident, but... Ooh, dang, we made that one really fast. I love it. Now, I'm going to be really happy if for all those changes we made part 3 fast. But I will not hold my breath. Yeah, there's where my breath would be held. I don't think that number is right. Yeah, that's not going to work. Reload the window. So yeah, I know part 1, zoom in, part 2, zoom in, part 3 example. So that was a chunk of time. Let's see if this... Ooh! What do you know? Not going through billions, or whatever that next one is, makes things pretty fast. Okay, I am loving it. I think this is where I'm going to call that refactor. Could say goodbye to the old code. Optimize 08 solution, and I am gonna be bad. I'm gonna try and look really quickly, see if I can get Wallaby up on this, because it actually has a great feature where, I mean, you could use other tools to get the same information, but it's got a profiling bit where it can let me know where things are being slow. Okay, so this doesn't... At one point, I use this feature or a feature like it to tell me which parts were running slow, but I'm not seeing that with my eyeballs. Yeah, okay, never mind. Okay, yeah, that is it for the Quest 8 refactoring. I suppose I can walk through it one last time, because I kind of started refactoring when I was planning to walk through it. But it should be mathematically kind of clear. We start at layer 2. We start with our thicknesses of 1. Calculate the width, which is layer plus layer minus 1, just a pattern of it. We calculate the latest thickness, which is the previous thickness, using the cool function, which uses acolytes and does that weird modulus multiplication addition stuff. We calculate the highest point by adding all the thicknesses together. We then calculate how much space we left as empty by going through every thickness but the last two, it's like the current one, and calculating how many empty cells would be for that column. And this is a left and right, so we multiply it by 2. Lastly, I guess initially, we also calculate how many are empty for the middle column, how many are needed for this layer, which weirdly enough doesn't include how many are left as empty space, but it works, so I'm not going to question it. If it was very close, we might need to include this in here, but we're good. Same logic as before. If we have enough, then consume it, go to the next iteration. If we don't have enough, we're down here, where we calculate how many we've spent, and we use that to add how many are needed for this layer minus the empty space to give us the total amount of blocks, including this layer. We return all these 3, which is how many we are missing, the width of our thing, and the total to this layer. Which, instead of width, I could just return layer number, but it's alright. And then for the part 1 and 2, we just multiply width and missing, and for the third one, calculate how many were needed to get to the layer, minus how many we had, which gives us, like in the example of 162, we had 160, 162 minus 162. I'm gonna do the dangerous by throwing this on here. Let's see if that doesn't break anything. Everything's still pretty fast, so let's just hit it. No. Yeah, I was the fool. But yep, that is Quest 8 all refactored. Pleasure as always.